To determine the minimum wire gauge for a duplex with two separate units, each having a 150 amp panel sharing a meter box with 2 meter sockets and one 2-inch pipe through the roof, we need to follow the National Electrical Code, or NEC, guidelines and perform some calculations. Firstly, calculate the total ampacity required. The ampacity is equal to the panel amperage multiplied by 1.25, which accounts for 25% dirting for multiple units. This dirting ensures that the wiring can handle continuous loads safely. In this case, the panel amperage is 150 amps, so the calculation is 150 amps multiplied by 1.25, which equals 187.5 amps. Secondly, determine the minimum wire size based on the calculated ampacity and voltage drop considerations. According to the National Electrical Code Table 310.15, B16, which provides ampacity ratings for conductors, a number 2 American wire gauge or AWG copper wire has ampacity of 195 amps at 75 degrees Celsius. This ampacity is sufficient for the required ampacity of 187.5 amps calculated earlier. It's important to note that the ampacity of a wire varies depending on the insulation type and the temperature rating. Always refer to the NEC tables for accurate values. Additionally, it is essential to ensure that the voltage drop in the feeder cables does not exceed 3%. Excessive voltage drop can lead to inefficient operation of electrical equipment and potential safety hazards. The voltage drop depends on the length of the feeder cables, the current flowing through them, and the wire gauge. The formula for voltage drop is voltage drop equals 2 multiplied by K multiplied by A multiplied by D divided by the circular mils, where K is a constant representing the direct current resistance of the conductor material, I is the current in amps, and D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor. Since the length of the feeder cables is not provided, we cannot calculate the exact voltage drop. However, number 2 AWG copper wire is generally sufficient for residential applications, even with longer feeder cables. If the feeder cables are exceptionally long, it may be necessary to increase the wire gauge to minimize voltage drop. To calculate voltage drop, you would firstly determine the appropriate K value for copper, which is approximately 12.9 ohms circular mils per foot. Secondly, measure or estimate the one-way distance, D, of the feeder cable run in feet. Thirdly, determine the circular mils for the number 2 AWG wire. This can be found in NEC Chapter 9, Table 8. Fourthly, plug the values into the voltage drop formula. Calculate the voltage drop. Fifthly, calculate the percentage voltage drop by dividing the voltage drop by the source voltage, typically 120 volts or 240 volts, and multiplying by 100%. Sixthly, if the percentage voltage drop exceeds 3%, consider using a larger wire gauge. As the final step, confirm the conduit size. The 2-inch pipe through the roof is sufficient to accommodate the number 2 AWG feeder cables. According to NEC Table 310.16, a 2-inch conduit can accommodate up to 4 number 2 AWG THHN copper conductors. THHN insulation is a common type of insulation for building wiring and is suitable for dry and damp locations. When installing the feeder cables in the conduit, ensure that you follow the NEC guidelines for full capacity. Overfilling a conduit can lead to overheating and damage to the conductors. To ensure compliance with the NEC, consult the relevant tables and articles in the code book. The NEC is updated regularly, so it's essential to use the latest edition. Some key articles to review include Article 210, Branch Circuits, Article 215, Feeders, and Article 310, Conductors for general wiring. Always consult with a qualified electrician or electrical engineer to ensure that your electrical installation meets all applicable codes and standards. Electrical work can be dangerous, so it's important to take precautions to prevent electrical shock and other hazards. Be sure to turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the job. Here's a summary of the key steps to determine the minimum wire gauge for duplex with two 150 amp panels. Firstly, calculate the total ampacity required, taking into account the 25% dirting for multiple units. Secondly, determine the minimum wire size based on the calculated ampacity and voltage drop considerations using NEC tables. Thirdly, confirm that the conduit size is sufficient to accommodate the feeder cables, following NEC guidelines for fill capacity. By following these steps and consulting the NEC, you can ensure that your electrical installation is safe and compliant with the code.